So you want to own a data center. First, you need to understand what you are actually selling. A data center does not make data. It provides a highly controlled place for other companies to store the computers that hold their data, run their websites, process payments, stream videos, operate artificial intelligence models, and quietly remember every password you have already forgotten. Your customers may bring their own servers and rent space inside your building. You could provide service for them, or you could build an enormous facility for one major technology company that wants thousands of machines operating under the same roof. The business model changes, but the basic promise remains the same. Their computers will remain powered, connected, secure, and cool, no matter what happens. That last part is what makes a data center expensive. From the outside, the building may resemble a windowless warehouse. Inside, it contains rows of server racks, fiber connections, electrical equipment, cooling systems, batteries, generators, fire suppression, security controls, and enough backup systems to suggest the building has serious trust issues. Before construction begins, you need the right location. Cheap land helps, but electricity matters far more. A large data center can consume as much power as a small city, and connecting one to the grid may require new substations, transmission equipment, and years of negotiations with the local utility. You are not simply asking for electricity. You are asking the utility whether it has several hundred megawatts sitting around with no immediate plans. The site also needs access to multiple high-capacity fiber routes. One internet connection is not enough. If a construction crew cuts the wrong cable 10 kilometers away, your customers will still expect their businesses to remain online. Redundancy is the central religion of data center ownership. 2 power feeds are better than 1. Backup generators support the grid. Batteries cover the gap until those generators start. Multiple fiber providers connect through different routes. Cooling systems have their own backups. Your backup systems may eventually require backup systems. Land near reliable power and major fiber routes has become extremely valuable. A property that looks completely unremarkable may be worth millions because several important cables happen to pass beneath the road. You will also need permits, water access, or another cooling strategy, environmental approvals, and a community willing to accept an industrial building that consumes enormous amounts of electricity while creating fewer permanent jobs than its size might suggest. The building may occupy several 100,000 square feet. Most of it is there so computers can sit quietly and become warm. Then you have to build it. Data centers are usually measured by electrical capacity rather than floor space. A 20-megawatt facility can support far more computing equipment than a smaller building designed for ordinary business use. Industry construction estimates have often landed around several $1 million for each megawatt of capacity. That means even a relatively modest commercial facility can cost well over $100 million before the customer installs a single server. A large hyperscale campus may require billions. This is why the industry includes major technology companies, real estate investment trusts, infrastructure funds, pension funds, and investors who consider $500 million a reasonable opening conversation. The electrical system is one of the largest costs. Power arrives from the grid, moves through transformers and switchgear, then reaches rows of servers through carefully managed distribution equipment. Uninterruptible power supplies keep everything running during brief interruptions, while generators stand ready for longer outages. Those generators need fuel. If the grid fails during a storm, you cannot discover that your emergency fuel contract was more of a suggestion. Cooling is the next challenge. Servers generate enormous amounts of heat. Traditional facilities use powerful air conditioning systems to push cool air through server rooms and remove hot air from the equipment. More intensive computing, particularly artificial intelligence, is encouraging operators to use liquid cooling, because air can only carry away so much heat before the building starts resembling a very expensive toaster. Cooling also affects where you build. A colder climate may reduce cooling costs. A hot region may offer cheaper land or favorable taxes, but require more energy to keep equipment operating safely. Some facilities consume significant amounts of water, which can create opposition in drought-prone areas. Your business is now competing with nearby residents for electricity and possibly water. Public relations may require more than pointing out that everyone enjoys the internet. Once construction is complete, you need customers. The simplest model is co-location. Companies rent cabinets, cages, or private rooms and install their own equipment. You charge recurring fees for space, electricity, cooling, security, internet connections, and technical support. A customer may begin with one cabinet and eventually expand across an entire room. Large customers may lease several megawatts at a time. Another model is wholesale data center leasing. Instead of renting individual cabinets, you lease large blocks of capacity to cloud providers, financial institutions, telecommunications companies, or technology firms. Then there are hyperscale facilities. These are enormous campuses built for companies such as cloud providers and artificial intelligence developers. The customer may sign a long-term agreement before construction begins, giving you predictable revenue and making financing easier. It also means one customer may control most of your income. Losing them would leave you with a specialized building, an enormous power bill, and several thousand empty places where computers used to live. The revenue can be attractive because customers do not like moving. Relocating servers requires planning, technical staff, new connections, and the possibility that something important stops working. Once a company installs critical equipment inside your facility, it may remain there for years. That creates recurring income. You collect rent for the space, charge for electricity, sell internet connections, provide cross-connects between customers, and offer services such as monitoring, maintenance, security, and equipment installation. A cross-connect is essentially a physical cable connecting one customer to another inside the building. You may charge recurring monthly fees for that cable. Congratulations! You have found a business where even a short wire can become a subscription. But the facility must operate continuously. Technicians monitor temperature, humidity, electricity use, network connections, batteries, generators, fire systems, and physical security. Guards control access, while cameras record movement throughout the property. Customers may require identification checks, biometric scanners, locked cages, and detailed records showing exactly who approached their equipment. A stranger wandering through the server room is generally considered poor customer service. Maintenance must be performed without interrupting operations. Electrical equipment needs inspection. Generators need testing. Cooling units need repairs. Batteries eventually need replacement. Every change must be planned, because one mistake can disconnect banks, hospitals, online stores, streaming platforms, or thousands of businesses that assumed your building would never have a bad day. Reliability is often described through uptime percentages. The difference between 99.9% availability and 99.9999% sounds tiny. Over a year, it can represent the difference between hours of disruption and only seconds. Customers pay heavily to remove those additional decimal points. Insurance, staffing, property taxes, financing, equipment replacement, and electricity remain major expenses. Power may be passed through to customers, but price increases can still make your facility less competitive. There is also the risk of technological change. New servers may require far more electricity per rack. Cooling designs may become outdated. Customers may demand renewable power. Utilities may delay new connections because the local grid cannot support another project. You could own land, permits, financing, and a completed design, then discover that the electricity will not arrive for several years. The building exists mostly to consume power, so this is a fairly important detail. Could an ordinary person realistically own a data center? A hyperscale campus is probably out of reach. It requires enormous capital, utility agreements, experienced engineers, major customers, and the patience to navigate years of development. A smaller facility is more achievable. You could purchase an existing building, develop a regional co-location center, specialize in secure local hosting, or serve businesses that need their data stored within a particular country or region. You could also own the real estate and lease it to an experienced operator, rather than running the technical systems yourself. So, what would owning a data center actually look like? You would control one of the hidden buildings supporting modern life. Customers would pay you every month to keep their computers powered, connected, protected, and cold. The revenue could be stable, and demand is growing rapidly. But entering the industry may require hundreds of millions of dollars, access to scarce electricity, and a building designed around the possibility that almost everything will eventually fail. You can own a data center. You just have to build a facility that never sleeps, rarely makes noise, and becomes most noticeable at the exact moment something goes wrong.